Okay, right. So divide by 160, am I right? Then we put our water. Water becomes 2,257 divided by 18. What's the answer here? Which one are you talking about? Huh? 4 over 160. Yeah, that's the one. What's the answer? 0,025. 0,025. All right. Then the other one, what does it become? 2,257 divided by 18. Then I get a long number there, 0,1253 and so on and so on, isn't it? But mine, since the first one is 3 decimal places, I'll keep this one 3 decimal places as well. Then I check which one is the smallest. Huh? 0,025. How do you see that is the smallest? You check your, what is this? What do we call this? No, this is not units. Units is this. This is units, this one. After comma, this one becomes a tenth. It's 1/10. This one becomes 100th. This one becomes 1,000th. Huh? So you check again here. This is your unit. This is your tenth. Tenth means 1/10, and this is 100th, which is 1/100. And this is the 1,000th, 1/1,000. So you must check, compare. You start with the units. Units 0, 0, isn't it? So they are the same here, isn't it? Then you go to the next one, tenths and tenths. Here there are 0 tenths, and here there's 1/10 here. Do you see that? Right. So here tenths are bigger than 100th. So your tenth here is 1. So this is the biggest. This is the smallest. So you're going to divide this one by the smallest, which is 0,025, divide by 0,025. Then here you get 1:5. Right, so your number of moles of water is 5. Number of moles of water is 5. Number of moles of water is equal to 5. That's your answer. Any questions? Right, mark allocation, you get subtraction, dividing, ratio, answer. Actually, it was 4, ne? It was 4. So I'm going to take away 1 here. I'll just take away this one here because you've used it here. So you get 4. Right. It's 4 marks. Clear? Right. Yes. Zinedine, you want to ask?
No, sir, I said yes because you said it's out of 4. So I'm saying, okay, yes.
All right, so we are done. Let's add the marks. So your marks is going to be 4 plus 2 plus 4. That makes it 10. 10 plus, I said this was how much? I said this was how much here? Focus of it with the 3, the 1,9. I said it was 5. So it's going to be 15. Then the other top one there, we also give it, this was how many water molecules? You said this was how much? 8 or 7. Did you write it as an example? Yes. Okay, so let's leave that one out. So give a total out of 15. Total out of 15. If my calculation is correct, give it out of 15. Leave number 1 because we did it as an example. Right. I move on. I move on to today's work, which is concentration. Concentration. So let's look at concentration. Let's look at concentration. Right? How do you define concentration? What is concentration? It It is the amount of solute dissolved in a given volume of solution. Yes. It is the amount of solute dissolved in a given volume of solution. Amount of solute. What is solute? There's solute, then there's solvent. It is the amount of solute dissolved in a given volume of solution. And your amount of solute, that is number of moles, it's normally the units are moles, and your volume must be in dm cubed or cubic decimeters. And 1 cubic decimeter is the same as 1 liter. 1 cubic decimeter is the same as a liter. Right? Then you've got your formula there, concentration, and the units are mole per cubic decimeter is equal to mole divided by volume. Mole divided by volume. Or you can say the amount of substance divided by volume. Amount of substance divided by volume. Okay, that one you can leave that one out. I'll just explain what's happening there. Right. Sometimes mole per cubic decimeter is shown as capital letter M. And what does M stand for? It stands for molar concentration or molarity. So concentration, if the units are mole per cubic decimeter, we call it molarity. That's another what? Synonym. Is it a synonym? Words with the same meanings, what do you call them? Antonyms. Is it antonym? Antonym is what? Opposite. Yeah, so it's a synonym. Okay. All right. You know grammar, we forget about the grammar. Okay. So it becomes your synonym. Words with the same meaning. What about names with the same sound, but they are homonyms? Okay. All right. Okay. Right. So these are synonyms. Molarity and concentration, they mean the same thing. Molarity and concentration means we're talking about mole per cubic decimeter. But your concentration, your units can change. So here, that's why we are being specific. Mole per cubic decimeter, that's molarity, right? So molarity, always the units must be mole per cubic decimeter. But I can change my units for concentration into grams per liter. It's also concentration. I can have grams per liter. But for molarity, it must always be mole per cubic decimeter. Right. So you find some chemicals, they write 1m. 1m, whenever you see 1m, it does not mean 1 meter here. Yeah? Whenever you see on a container, it's written 1m, it means 1 mole per cubic decimeter. Is that understood? Whenever you see 2m, it means 2 moles per cubic decimeter. 3m, 3 moles per cubic decimeter. That's written in molarity. Is that understood? Right, fine. Then the concentration of, so I'm just repeating here, the concentration of a solution usually is a solid in a liquid solution refers to the number of moles of solute in relation to the volume of the solution. Just back, we've got solute and we've got solvent. What is a solute? We did this in grade 7, grade 8, grade 9. What is a solute? What is a
It's the
solvent?
substance that dissolves in the solvent, normally in smaller quantities.
Right, so solute is a substance in lesser quantity. That's a solute. So when you take sugar, you put it in your tea. Your sugar is your solute because your sugar is lesser than the quantity of the water or your tea or your coffee, whatever it is. Clear? Then your solvent is the substance that is in a larger quantity. So your water becomes your solvent. Is that clear? Water is not the only solvent. There are many other things that act as solvent as well. Right. So the molar concentration of a solution is the number of moles of solid per unit volume in cubic decimeter of solid. Please, can you write this alternative definition here? The one written in maroon here. Is that red? It looks like maroon. Red. You're colorblind. Is it red? It's maroon. How does it look? Red. The fire extinguisher next to you, that's red. That's red. And when are your bandana? That's red. Yeah, that's red. All right, so the molar concentration of a solution is the number of moles of solid per unit volume in a cubic decimeter solution. Please, I think I've highlighted cubic decimeter is the same as a liter. Yeah? Cubic decimeter is the same as a liter. Cubic centimeter is the same as milliliter. So your teaspoon is 5 milliliters. So it's the same as 5 cubic centimeters. When you go to the doctor, they say you must drink 5 mils of medicine. It means you must take 5 cubic centimeter of medicine. Yeah? Cubic centimeter, milliliter, one and the same thing. Liter, cubic decimeter, one and the same thing. Right. We move on. Only that line. That's an alternative definition to the one that you wrote it at the top. In case you're asking an exam, define concentration. So they're just going to say number of moles of solid per unit volume. Right. If the mass is given rather than the number of moles, then this has to be converted to moles, right, before the concentration can be calculated. If the volume is not given in cubic decimeter, it must be converted to that unit. So if you are given anything else, let's say they give you cubic centimeters, then you must convert it to cubic decimeters. I showed you how to convert units. I asked you to write somewhere in the back of your books sometime in first term, remember? We said King Harry died miserably, disease called malaria. I didn't do that? No, guys. Okay, let me do it now. I'll do it once. All right, King Harry died miserably, disease called malaria. So I'm going to start. King Harry died miserably, disease called malaria. You can come up with your own statement there. K for kilometers, hectometers. This one becomes decameters. This is meter. This is decimeter. This is centimeter. This is millimeter. All right, then the step here. The step here is 10. 10. 10. 10. 10. And 10. Just a factor of 10. Right? When I move, so here I'm talking about distance. I'm talking about length, distance or length, whatever it is. All right? So when I move from big to small, kilometer is big, millimeter is small. When I move from big to small, I multiply. So going that way, I'm going to multiply. When I move from small to big, I divide. When I move from small to big, I divide. Example, when I move from, if I've got 5 millimeters, I want to convert it to centimeters, I'm going to divide by 10. If I move from 5 millimeters, I want to convert it to decimeters, I'm going to divide by 10 times 10, which is 10 squared. 10 squared is 100. So I'm going to have 10 to the power 2. Are you following? When I move from millimeter to meter, I'm making how many steps? 1, 2, 3. It means 10 to the power 3. 10 to the power 3 becomes 1,000. If I change from millimeter to kilometer, right? How many steps am I making? 1, 2, 3, 4, 5, 6. It becomes 10 to the power 6. 10 to the power 6 is a million. So for me to change millimeter to kilometer, I have to divide by a million. 10 to the power 6. Are you following? Right, that's distance. I'm done with that one. Right, then we go to area. When you speak of area, I'm going to do it again. I'm going to have the same thing. King Harry died miserably, disease called malaria. I've got millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer. Right, but now when I speak about area, what is the formula for area of a rectangle or area of any? It's going to be length times breadth, and my units are going to be square. They're always square units. They're always square units. So it means here my units are going to change. It's going to be square, 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 square meter, square decimeter, square centimeter, square millimeter. My step here is a 10. Originally, when I talk about length, it's 10. My step here is 10, 10, 10. But now, because I'm doing square, my distance changes to become 10 squared. My step is now 100, because 10 squared becomes 100. So when I'm talking about area, when I move from square millimeter to square centimeters, right? I'm moving from big to small. The direction does not change. When I move from left to right, I multiply. Moving from right to left, I divide. So when I change square millimeter to square centimeters, I'm going to divide by 10 squared, which is 100. When I move from square millimeter to square decimeters, I'm making 2 steps. So it's a step of 100 and 100. So it becomes by, it's going to be 10 to the power 2 plus 10 times 10 to the power 2. It becomes 10 to the power 4. What is 10 to the power 4? It's 10,000. Are you following? Because it's 100 and 100. 100 times 100 gives me how much? 10,000. When I move from square millimeter, hello? When I move from square millimeter to square meters, it's going to be 10 squared, 10 squared, 10 squared. So it's going to be rules of exponents. When you're adding same base, what do you do to the exponents? You add. So it's going to be 2 plus 2 plus 2, which is 6, 10 to the power 6, which is a million. So when I move from square millimeters to square meters, I'm going to divide by a million. Are you following? When I move from square millimeter to square kilometers, I'm going to make how many steps? 1, 2, 3, 4, 5, 6. But each step is 100. So I'm going to make power what? 2, 4, 6, 8, 10, 12. It becomes a trillion. So for me to change from square millimeters to square kilometers, I need to divide by a trillion. 10 to the power 12. Are we together? Good. Right, that's area. We go to volume. We go to volume. Volume, I'm going to do again. King Harry died miserably, disease, cold, malaria. Meter, 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 Then I've got decimeter, centimeter, millimeter. My step here, still a 10 here. 10, still 10, but I'm going to make changes to that. 10, 10. Now when I do volume, formula for volume is length times breadth times height. So my units are going to be cubic units. It's going to become to the power 3 cubic units. Right, so my kilometer here becomes cubic kilometer, cubic hectometer, cubic decameter, cubic meter, cubic decimeter, cubic centimeter, cubic millimeter. My step is going to change. Instead of 10 to the power 1, I now have 10 to the power 3, 10 to the power 3, 10 to the power 3, which is 1,000. My step changes to 1,000 when I speak of volume. Because the 10 that I had here, I say 10 by 10 by 10, which becomes 1,000. When I move from cubic millimeter to cubic centimeter, moving from right to left, I divide as up here. From small to big, I divide. So I'm going to divide by 10 to the power 3, which is 1,000. If I move from cubic centimeter to cubic decimeter, I divide by 1,000. If I move from cubic millimeter to cubic meter, I'm going to make how many steps? I'm going to make 3 steps. 1, 2, 3. But each step is a power 3. So rules of exponents, I'm going to add 3, 3, 3, which is 9. So for me to move from cubic millimeter to cubic meter, I'm going to divide by a billion, which is 10 to the power 9. Is that understood? From cubic millimeter to cubic kilometer, I'm going to divide by 10 to the power is 3, 6, 9, 12, 15, 18. I'm going to divide by 10 to the power 18. Clear? Which is going to be how much in millions? It's going to be your trillion, quadrillion, and quintillion. So how many threes? That's 1,000. That's here 3 zeros, million. That's a billion, trillion. That's a quadrillion. That's a quintillion. I divide by quintillion. Yeah? Okay, fine. Right. Okay, fine. So this you must know this. Just to your cubic centimeter is the same as milliliters. So cubic milli is the same as milliliters. Cubic decimeter is the same as liters. So those are the ones that we normally use most of the time. We use milliliter, and milliliter is cubic centimeter. Cubic decimeter is your liter. Are we together? Those are the common ones that we use when you go buy your cooking oil, your food drink, your paraffin, whatever. You use liters, but they are the same as cubic decimeters. So these are the units that you must remember every time, so that when you do your conversions, you understand. That's going to apply both to maths and science and life sciences. Okay, so that's the one part. Please just keep it at the back of your book, and whenever you want to convert, you refer to this in terms of distance, area, and volume. Any questions? Right, I can move on here. Right, so let's go back to what we're talking about. This laptop tired. Okay. Okay. Right. Let me finish up. Right. Our time is almost up. The equation for calculating molar concentration becomes C is equal to N over V. That's the formula that we use. C is equal to N over V. Please just write that one quickly. C is equal to N over V. Where C is your concentration and the units mole per cubic decimeter. N is number of moles. V is your volume. Concentration is equal to number of moles over volume. Right. Can you wake him up there? He's sleeping now. Okay. Right. Concentration is equal to N over V. Right. Can I move on? I'm gonna post this one on Google Classroom. Right. Okay. Then we move on. We've got molarity. Molarity, we've spoken about that. Then let's look at an example. Example. If 3.5 grams of sodium hydroxide NaOH is dissolved in 2.5 cubic decimeter of water, what is the concentration of the solution in mole per cubic decimeter? So what are we given? We are given mass. What else are we given? We are given volume, isn't it? What do we need? We need concentration. So what are we going to say? According to our formula, according to the formula, what do I have? I've got only concentration is equal to number of moles over volume. So I need to get the N first. So I can get number of moles. How do I get number of moles? I use number of moles is equal to mass over molar mass. Is that clear? What is my mass? Mass is 3.5. So I substitute over the molar mass. Which substance am I talking about? I'm talking about sodium hydroxide. So I go to the periodic table and check what is the molar mass for sodium is 23. Molar mass for oxygen, 16. Molar mass for hydrogen, 1. I add that 23 plus 16 gives me 39. 39 plus 1 gives me 40. 3.5 divided by 40 gives me 0.0875. Those are my number of moles. I take those number of moles, I put them in the formula. C is equal to N over V. My number of moles, 0.0875, divided by the volume, which is 2.5. My answer becomes 0.035 mole per cubic decimeter. That's the concentration of that substance. You don't like to do it like this. You want to combine it into one. It's still fine. Let me just derive another equation that you can use without doing 2 steps. You can just do 1 step, right? So you can just say concentration is equal to number of moles over volume. We call this equation 1. This is what we have learned for now. So I call this equation number 1, right? But what do I know? I know number of moles is equal to mass over molar mass. I call this equation number 2. Then I substitute equation 2 into equation 1. Then what am I going to have? I'm going to have C is equal to, where there's N, I'm going to put mass over molar mass multiplied by volume. This becomes the other equation that I can use without using 2 equations, which is still the same. So I can have another equation, which is concentration is equal to mass divided by the molar mass and the product of molar mass and volume. So you can just write that equation, then you can use that one. If you don't want to go 2 steps, you can use that one equation. Where M is the mass, capital letter M is your molar mass, and V is your volume. Yes. Right, can I proceed? Right, let's wrap it up. Right, let's finish up that. There's a last example. The last example comes and says, how much sodium chloride in grams will one need to prepare 500 cubic centimeter of solution with a concentration of 0.01 mole per cubic decimeter? What are we looking for? We're looking for the mass. What are we given? We are given volume. The volume, is it in standard units? No, it's cubic centimeter. It's supposed to be cubic decimeter. You go to your conversion table, the one that I showed you now. You're moving from cubic meter to cubic decimeter. So you're going to divide by 1,000 because you're moving 1 step. Clear? All right. So you convert your volume to cubic decimeter, you divide by 1,000. It gives you 0.5 cubic decimeters. Right. Then you find your number of moles. But here we are going a long way because we are doing 2 steps. So you're going to calculate your number of moles first by using CV. Number of moles is equal to concentration times volume. Concentration we were given, that's the 0.01. Then the volume is the one that we converted here. So we're going to multiply these 2, then we get our number of moles. After we find our number of moles, what do? The question wants mass. We go to the equation of number of moles is equal to mass over molar mass. We substitute, right? Number of moles, we take the answer that we got up here, you put it here. After that, you substitute your molar mass. Molar mass of what? Sodium chloride. You go on the periodic table and check what is the molar mass of sodium chloride. Sodium is 23, chloride is 35,5, so you add the 2. Your answer becomes 58,5. Then you multiply, then your answer becomes 0,29 grams. If you don't want to use these two, you can use the equation that I showed you now. So you're just going to substitute into one equation, then you make your M mass the subject of the formula. Any questions? I'm done for the day. We've got 5 minutes. Right. There is exercise 32 for you guys. You're going to have to do this as homework where you calculate in concentration, exercise 32. All right, so I'm going to post this on Google Classroom now. All right, please, those who do not have data at home, please just download quickly in the last 2 minutes. Any questions for guys online? No questions. So I'm going to adjourn the meeting. I'll post this on Google Classroom. Please do the work. Let's meet tomorrow. Enjoy the rest of your day. Bye.